Hi, and welcome to this section of the pre-algebra tutor, and in this section we're going to work on subtraction of fractions. Now in the last section we did addition of fractions, and so you should have a pretty good idea that you have to have a common denominator in order to add fractions. Well, in this section I'm going to tell you you're also going to need a common denominator to subtract fractions. So addition and subtraction of fractions really are very, very similar. You check to see if the denominator is the same. If it is, then you can go ahead and add or subtract them. If it's not, then you're going to have to go ahead and get that common denominator before you do the addition or the subtraction. So really, I could have combined this section with the last one because addition and subtraction of fractions are so similar as far as the steps, but I wanted to split it apart so that you would have everything separate and so you could build your seal sort of separately. But just know that addition and subtraction of fractions is very, very similar. So to show you that, rather than just tell you that, let's go ahead and work a few problems. So what we're going to have, what if we have something like 3/8 minus 2/8? Well, the first thing you do is check to see if your denominator is the same. And in this case, it is the same because our denominator is 8. So basically what you do is you keep the denominator the same, just like we did for addition, so that part of it is exactly the same. Now here, since we are subtracting these fractions, we're going to subtract the numerators. So it's really doing the same operation that's in the center here, it's just that you're doing it to the numerators. Before, if this was plus here, we'd be adding 3 plus 2 in the numerator, but because we're subtracting these fractions, we end up subtracting those numerators. So 3 minus 2 is 1. The denominator stays as 8, so the answer is 1/8. Now this step right here in the middle, where I'm writing out the subtraction of the numerators, that's going to be up to you. Some of these problems in the beginning, I'm going to do that. I'm going to show you. I'm going to write it down so that you'll know what I'm doing. But really, as you start subtracting fractions, much like when you started to add them, you might write that in the beginning to remind yourself what you're doing. But really, you just need to look at these things and say, well, the denominator is the same, so I'm going to leave it, and then I'll just subtract the numerators. 3 minus 2 is 1. You could just write down 1/8 because this problem is so simple. But notice that it is very similar to addition because really you're checking the denominator first, and then you're doing the actual step. So what if we had something like 7/9 minus 1/9? So I check to see if the denominator is the same, and it is. So the denominator stays the same. In the numerator, because I'm subtracting, I'm going to have 7 minus 1. So 7 minus 1 is 6/9. Now, just like with every fraction problem, the answer that you get, which is in this case 6/9, we always check to see if it's simplified. And we look at this and we say, well, I can divide this by 3, and I can divide the bottom by 3 because I can divide the top and the bottom of a fraction by anything I want, just like I can multiply the top and the bottom of a fraction by anything I want, as long as I do it to the top and to the bottom of the fraction. So 6 divided by 3 is 2, 9 divided by 3 is 3, so the answer is 2/3. Okay, now let's keep going. Let's say we have something like negative 1/5 minus 3/5. Okay, so I look and I see, well, yeah, I've got negative 1/5 and all that, but the negative part really doesn't enter into it in the beginning. The first thing I do is check and see I do have a common denominator, so I keep it. I don't do anything special. I just keep that denominator. In the top, I've got negative 1 minus 3. The negative 1 minus 3. So that's what I have in the numerator. So negative 1 minus 3 is negative 4 over 5. And you can leave the answer like that. When you have a fraction and you have a negative sign, the negative can be in the top, it can be in the bottom, or most of the time you'll see it written right out front. Either way to write it is correct. It doesn't really matter where you put this negative sign, but most books and teachers like to see it written out front. So if you get something like this, or if you did it differently and you get it on the bottom, just pull it out right in front of that fraction there. Negative 4/5. Okay, what if we have 2/5 minus 4/5? 2/5 minus 4/5, all right? So we have the same sort of deal. We have the same common denominator, which is a 5, so we're going to put that there. What about the numerator? We're going to have 2 minus 4. 2 minus 4. And thinking back to subtraction of integers, 2 minus 4 is negative 2 over 5. I could leave it like this, but I'm going to bring that negative out, even with the fraction bar there, negative 2/5. Okay, what about 3/8 minus 5/8? 3/8 minus 5/8. Same sort of thing. Let's check the denominator. It is the same. I'm going to have an 8. And in the top, I've got 3 minus 5. 3 minus 5 in the top. So 3 minus 5 is negative 2 over 8. All right. Now I can rewrite this with the negative sign out front, 2/8, but notice that this fraction is not fully simplified because I can take the top and the bottom and I can divide by 2. That's going to be negative. 2 divided by 2 is 1. 8 divided by 2 is 4. Negative 1/4. So this fraction, the negative 2/8 and the negative 1/4, they're exactly the same fraction. This is just a little bit written a little bit simpler. Okay. What about negative 9/16 minus 12/16? Minus 12/16. Denominator is the same, so I write that as the same. And in the top, I've got negative here, so I can't just disappear it and just not fool with it. It's negative 9, so I have negative 9 on top minus the 12. That's how I take into account all of the signs on the top. Now, remember, when we do subtraction like this, integer subtraction, negative 9 minus 12 is going to be negative 21 over 16. Negative 21 over 16. And notice that this is an improper fraction, so I can write this as negative, pull the negative sign out. How many times will 16 go into 21? How many times will it divide in? It's only going to divide one time, which gives me 16. And if I take 21 minus 16, I'm going to get 5. That's the remainder. And I express it as a fraction over 16 because that's my denominator. So I express that remainder as 1 5/16. All right. What if I have 7/9 minus negative 5/9? So I'm subtracting a fraction, but the fraction I'm subtracting is actually negative, so I need to write it like that. Now this is really no different than integers. When you are subtracting a negative thing, you can just basically add the opposite. So what that's going to be is 7/9 plus 5/9. A lot of times you'll see people do this. They'll add the opposite. So sort of a double negative there, and it cancels. So you basically are going to get this plus. So 7/5 plus, 7/9 plus 5/9. But this is just an addition problem. We've done this before. So the denominator is the same. We add the numerator. 7 plus 5 is going to give me 12. So I've got 12/9. And then this is an improper fraction, right? 12 is bigger. So how many times will 9 go into 12? It's only going to go one time. So if I find the remainder, 12 minus 9, is going to give me 3, 1 3/9. So that is the answer. I could circle that guy, but it's not quite simplified because when you think about it, I can take, for the fraction, forget about the 1, for the fraction I can divide the top by 3 and I can divide the bottom by 3. So it's going to be 1 and 3 divided by 3 is 1. 9 divided by 3 is 3. So 1 1/3. That's going to be the answer there. So it's really kind of a bulletproof process. You look at the denominator, you keep the denominator, and you subtract. And sometimes when you end up subtracting in the numerators, you might have a double negative here, so you add the opposite, it becomes addition, which you've already done before. So you really do need to be good at your integer subtraction and addition, which we did a long time ago, and that's why it's so important, because it builds and builds. If you can't do that, then you can't do fractions. If you can't do fractions, then you won't be able to do other things later down the road that we haven't gotten to yet. So let's work a few more problems when the denominator is already the same, and then we will work some problems when we don't have a common denominator and we have to find it ourselves. Okay, so what about negative 15/16 minus negative 1/16? So we have the same kind of thing here. We've got a problem where we're subtracting a fraction, but the fraction we're subtracting is actually negative. So we can sort of add the opposite here. So this is going to be negative 15/16 plus 1/16. So it becomes an addition problem. So we look at this guy and we say, okay, well, the denominator is the same, 16. In the numerator, I'm going to have negative 15 plus 1. Don't forget about this negative that's here. You can't just discard it. So that's still negative 15 plus 1. And so I know that this is going to be negative 15 plus 1 is negative 14 over 16. And those are both even numbers, so I can definitely simplify this. I'll take the negative sign out front, and I'll say what I'm going to end up doing over here is I'm going to divide by 2 and divide by 2. So what's 14 divided by 2? That's 7. And 16 divided by 2 is 8. So negative 7/8. Negative 7/8. All right, what if I have, let's get into something a little bit different. What if I have 7 and 4/5, so a mixed fraction, minus 5 and 2/5? All right, 5 and 2/5. So I recommend when you're dealing with these mixed fractions and subtraction problems like that, just to go ahead and convert them to improper fractions first and then do your subtraction. I mean, there are other ways to do it, but really that's the easiest way to get where you want to go. So let's go ahead and convert this. How do we convert this? 7 times 5 is 35, plus 4 is 39 over 5, because we're writing it over the denominator, minus 5 times 5 is 25, plus 2 is 27 over 5. So we have 39/5 minus 27/5. So what I'm going to have in the bottom, the denominator is the same. It's 5, so it stays. What's 39 minus 27? That's going to be 12, if you do that. So we have 12/5. Now this is improper. How many times will 5 go into 12? It'll go 2 times. So 5 times 2 is 10. And so the remainder, 12 minus 10, is going to be 2. And I write it as 2 over 5th. So 2 and 2/5. You know, there are other ways to do this, but it's just easier. Convert it to improper, convert it to improper. Do the subtraction the way you know. If the answer is improper, convert back. It's just going to be a little bit, I think, shorter overall for you. What if we have 8 and 2/7 minus 4 and 1/7? 8 and 2/7 minus 4 and 1/7. So let's go ahead and convert to improper. So 8 times 7 is 56, plus 2 is 58 over the denominator, which is 7, minus 7 times 4 is 28. 28 plus 1 is 29 over 7, because that's our denominator. So what we're going to have here, the denominator is 7, so it stays the same. 58 minus 29 is going to actually give you 29. Right? So we have an improper fraction here. How many times will 7 go into 29? 7 times 4 is 28, so it's going to go 4 times 28 there. And so the difference, 29 minus 28, is 1. The remainder is 1/7, because we always write it over the denominator. 4 and 1/7. Now, it's important to know, just like I did in the addition section, that we're dealing with numbers here. You know, we're always dealing with numbers so far in the beginning because it's easy to wrap your head around. But in algebra, a lot of times you're dealing with variables that are letters mixed in here. So a lot of people, you know, they get worried when they start to see letters because it's a little different looking. Well, when you have a fraction that has a variable in it, just treat it exactly as if it were a number and apply the rules. Make sure you're doing everything legal. Don't worry about the fact that it's a letter. So let's look at some easy ones like that. What if we have 8 over x, whatever x is, I don't even know, minus 3 over x? How would you handle that? A lot of people would look at this and not have any idea what to do, even though they already know how to do all these other problems. Well, x is a denominator, right? It's just an unknown denominator. You don't know what it is. So the denominator of your answer is going to be x, because it's already the same denominator in both cases. If it were 8 over 4 and 3 over 4, the denominator would be 4. Here, the denominator is just x in both cases, so the denominator of the answer will be x. All right, so on the top, 8 minus 3, we just do the subtraction. It's going to give me 5. See how easy that is, 5 over x, right? What if we have 9 over a minus 14 over a? Minus 14 over a. Same kind of thing. We already have a common denominator, which is a. So we write that down. That's my common denominator. Now, 9 minus 14, let me just write it here just so you see what we're doing here. 9 minus 14. What is 9 minus 14? That's negative 5 over a. And this negative can be anywhere. I'm going to go ahead and bring it out in the front, 5 over a. So we have negative 5 over a. All right, so up to this point, we have done all of these subtraction problems, and the denominator so far has been the same. So it's been really easy. We've just kept the common denominator, we've done the subtraction in the numerator, and we simplified the answer. That's the steps over and over again. We're just building our skills. Now, just like in addition, you're going to have cases when you don't have a common denominator. So you just do exactly the same thing that we did in the last section, which is find your own common denominator, and then do the subtraction, and then do the simplification. So we're going to get good at that here. So what if we have 3/4 minus 2/3? 3/4 minus 2/3. So we don't have a common denominator. We have a 4 and we have a 3. Now I'm going to have to work with both of these fractions in order to get a common denominator. So let's do that. 3/4 minus 2/3. So what can I multiply by? The sort of the least common multiple between these two guys is going to be 12. So if I multiply this one by 3, and if I multiply this one by 4, then I'm going to get 12 as a denominator in both cases. So what I'll have is 3 times 3 is 9/12, minus 2 times 4 is 8/12. Now I have a common denominator, and now the problem is very easy to solve because I just keep the denominator, subtract the numerators. 9 minus 8 is 1, so I have 1/12. What if I have 5/12 minus 3/4? So I don't have a common denominator, but I know if I take this 4 and I multiply by 3, I will get 12. So let me do that. So I'll have 5/12 minus 3/4. Now what can I multiply by? I can multiply by 3/3 like this. And that's going to give me 5/12 minus 3 times 3 is 9/12, because the 12 is on the bottom now. And so what I'm going to have is 5 minus 9 in the numerator over 12, because the denominator is the same. 5 minus 9 is -4/12. And so basically I can simplify this fraction by dividing by 4, dividing by 4. And so what I'm going to have in the end is negative, don't forget the negative still there. 4 divided by 4 is 1, 12 divided by 4 is 3, -1/3. -1/3. All right, same steps as always. Check to see what denominator I can form. Do the multiplication to get that denominator. Keep the common denominator, subtract the numerators, simplify the answer. You're building your skills one step at a time, but you're doing the same thing over and over and over again. What about -2/5 minus 3/4? So again, no common denominator, but I look at this, I say, well, I'm not going to be able to multiply this by anything to give me 4. I'm not going to be able to multiply 4 by anything to give me 5. The least common multiple between these two that I can sort of think of off the top of my head is 20. So I'm going to do that. -2/5 minus 3/4. So let's work on that. If I multiply this guy by 4 and multiply this guy by 5, then my denominator will be 20, which is just what I'm trying to do. I'm trying to find any common denominator I can. Negative 2 times 4 is 8/20, minus 3 times 5 is 15/20. So now I have a common denominator, which is 20. So I'm going to put that down here. And in the top, don't forget the negative. -8 minus, from here, 15. So I just subtract those, which we learned how to do before. -8 minus 15 is going to give me -23/20, which is an improper fraction because there's a bigger number on the top. So how many times can 20 go into 23? Well, it can only go one time. So negative stays out front. It can go one time. 23 minus 20 means I'm going to have a remainder of 3/20, like this. I always write it over the denominator. So -1 and 3/20. So these problems really are not getting any harder. Maybe a little bit bigger numbers, but ultimately it's really doing the same thing over and over again. But I cannot stress enough how important fractions are to basic math and also to algebra, and then when you go on beyond algebra into all of the branches of math, basically everything's going to end up being a fraction. So being able to find a common denominator, being able to be comfortable manipulating fractions, so crucial to everything you do. So that's why we're doing so many problems in this section, to make sure that you really, really feel like you understand it. What about 4/a? Actually, let me go ahead and pick 4/9 minus 4/5. So again, no common denominator, but I think if I work with this, the only common multiple I can really find, the least common multiple I can find, is just multiplying them together. 9 times 5 is 45. There's nothing else I can think of that I can divide 9 into and 5 into that could be a good common denominator. So I'm going to multiply this fraction by 5, and I'm going to multiply this fraction by 9. So 4 times 5 is 20. 9 times 5 is 45. Minus 9 times 4 is 36 over 5 times 9 is 45. So what I have is 20 45ths minus 36 45ths. So what I'm going to have is the common denominator of 45 and 20 minus 36 in the numerator, just subtracting those. Now when you do 20 minus 36, you're going to get negative 16 in the top over 45. Negative 16 over 45. So I can just take that guy down here, negative 16 over 45, and that's the answer. And there's really no good way. I can't really divide by 2 in the top and the bottom. I can't really divide by 3. I don't really think there's a good way I can simplify that, so I'm just going to leave it exactly like that. All right. What if we had 3/16 minus 1/2? Well, in this case, I noticed that if I take 2 and multiply it by 8, I'm going to get 16. So I can just mess with that one fraction by itself. So what if I have 3 over 16, leave it alone, minus 1/2. And I'm going to take this fraction and multiply it by 8, and multiply it by 8. And actually, this is 3/16. Because this denominator will then give me 16. So when I do that, I'm going to have 3/16 minus 1 times 8 is 8/16. So the final answer is going to be over 16 because that's my denominator. 3 minus 8 is negative 5. So negative 5/16. And if you don't want to leave that negative up there, just leave it as down here, negative 5/16. But you could circle that as your answer. That's fine too. All right, now what if we have some mixed numbers here? What if we have some mixed numbers here when we start subtracting? What if we have 1 1/3 minus 2 1/2? 1 1/3 minus 2 1/2. So again, I recommend, just like we did before a minute ago, when you have these mixed numbers and you're doing subtraction like this, just go ahead and convert them to improper fractions. It's going to be a little bit easier. So 1 times 3 is 3, plus 1 is 4, 4/3. Okay, that's going to be this guy. Minus from here. 2 times 2 is 4, plus 1 is 5. And I write it over 2. Right? So I've converted them both. Now, the denominators are not the same. So I'm still going to have to deal with that, but at least it's basically now we have the same kind of problem that we've been dealing with all along instead of looking at these mixed numbers here. What common denominator can I find? If I do 4/3 minus 5/2, if I multiply this guy by 2 and multiply this guy by 3, then I'll get 6 on the bottom, and that will be a nice common denominator. So 4 times 2 is 8, 8 over 6, minus 3 times 5 is 15 over 6. So ultimately the answer is going to be over 6. That's my common denominator. What is 8 minus 15? Let me write it down like this so you can see what we're doing. 8 minus 15. So you're going to get a negative number. What's it going to be? It's going to be negative 7 over 6. Negative 7 over 6. Now this is an improper fraction. 7 is greater than 6. So I'll just keep this negative sign out front. How many times will 6 go into 7? It'll only go one time. What's the remainder? Well, if I go one time, I'm going to be subtracting 7 minus 6. The remainder will be 1, and then I always write it over 6. So negative 1 1/6. Okay, now the next problem, let's go ahead and say we have 2 1/2 minus 1 9/10. 1 9/10. So again, you're subtracting and you have mixed numbers. So let's go ahead and convert these mixed numbers to improper. So 2 times 2 is 4, plus 1 is 5. So 5/2. And then here we'll have a minus. And then 1 times 10 is 10, plus 9 is 19 over 10. 19 over 10. And so that's the fraction we have. Those are the two fractions we have. And we notice we have 2 and we have 10 in the bottom. And it's pretty easy because if I take 2 and multiply by 5, I'll get 10. So I'm going to work with that, minus 19 over 10. So what I'll do is I'll just work with this one fraction, multiply by 5, because that'll give me 10. I can do it to the top and the bottom, no problem. So what I'll get, 5 times 5 is 25 over 10, minus 19 over 10. The denominator will just be 10 because that's the same. And then I'll be dealing with 25 minus 19 on the top. What's 25 minus 19? That's going to be 6. So 6 over 10. Now this is the answer, but it's not fully simplified because I know that if I take this and divide by 2, I will get 6 divided by 3. I'm sorry, 6 divided by 2 is 3. And fifths. 10 divided by 2 is 5. So the answer is 3/5. Okay, the next problem is going to be negative 3 2/3 minus negative 4 1/9. So I'm subtracting two fractions, but this other fraction that I'm subtracting here is also negative. So when you look at this, you might say, well, I've got double negatives here. I can add the opposite. So ultimately, this problem is going to be negative 3 2/3 plus 4 1/9. So it's really an addition problem. And actually, this is negative out here because of this negative out in front. So let's go ahead and convert these to improper. 3 times 3 is 9. 9 plus 2 is 11. So negative 11/3 here. Plus 9 times 4 is 36. Plus 1 is 37 ninths. 37 ninths like this. So we have to add these guys here. We notice that we have a nice 3 and we have a nice 9. So we'll basically go ahead and work with this fraction right here. So if we have negative 11/3 plus 37/9, then if I multiply this times 3, like this, then I'll get a 9 on the bottom, which is what I want. So 11 times 3 is 33/9 plus 37/9. And so the answer is going to have a common denominator of 9. And this guy is going to be, what's negative 33 plus 37? If you think about that, negative 33 plus 37. That's going to be a positive 4/9. So the answer is 4/9. And just like I've been saying before, if you have letters, it's not a big deal. You just work with it the same way that you think you might work with it. So let's go ahead and take a look at one of those right now. What if we have a/3 minus b/2? So we have variables in there, but we know that our denominator is not the same. We know that the common denominator that we would shoot for usually would be 6 because, that's the least common multiple of these two guys. So if we do this, minus b/3, what would we multiply by? We would multiply the bottom, actually this is 2, like this. Now what we would multiply here, we'd multiply this by 2, we'll multiply this by 3. And that's just so that we can get a 6 in the denominator of both. So equals, a times 2 is just 2a. That's how you write it in algebra, with the letter right in front of the, or right after the number, 2a. Over 6 minus, what I have over there is just 3 times b, so 3b over 6. You don't have to really write any multiplication symbol if you have a letter and a number right next to each other. Now the common denominator that we have is 6, so the answer is going to be 6, and the top is just going to be 2a minus 3b. There's nothing else you can really do to the top. It's just going to be 2a minus 3b. You can't really add them together anymore because you've got the a and the b here. Those are different. We're going to work on that in a few sections from now when we start really talking about algebraic expressions. But for now, as a sneak preview, just know that when you're adding or subtracting things that have letters, you can only do it if the letters match. In other words, if I had 2a minus 3a, then I could subtract those things together. If I had 2b minus 10b, I can do something with that. But when I have something times a minus something times b, I can't do anything because this is like 3 times the number of pencils minus, or 2 times the number of pencils minus 3 times the number of golf carts. So a and b are completely different things, so you really can't add them together in the sense of algebra anyway. So we're not going to mess with it. We're going to leave it exactly like that. There's nothing more I can do with it. What if I have 2x over 5 minus y over 10? So again, looks kind of complicated, but when you think about it, I have 5 and 10 as my denominator. So I have a feeling that I'm just going to basically deal with the first fraction, because I can take that 5 and I can multiply by 2. And that's going to give me 10, which is a common denominator. So what's the top? 2 times x times 2. The numbers are the things that are multiplied together. 2 times 2 is 4. The x stays along for the ride. Minus y 10. So when you're multiplying something like this, again, we're going to get into a lot of this stuff later, that when you have a variable, just don't forget this variable. It's an unknown number. So yeah, I can certainly multiply these things together. I just don't know exactly what x is. So x just stays along for the ride. I'm still multiplying the answer times x. I just don't know what it is. 2 times 2 is 4. The x just stays along for the ride. Now I have a common denominator of 10, so I leave it. And in the numerator, I have 4x minus y. 4x minus y. And again, I can't do anything more with this numerator because when I'm adding or subtracting, you need to have, if you have variables mixed in with numbers, and we're going to get into this later, you can only really add or subtract them if they match, if the variables really do match with one another. So if I had 4x minus x or 4y minus y, I could subtract those. We'll get to that later. But when you have a mismatch like this, when you're adding or subtracting things and the variables don't match at all, you can't do anything. It's like adding buffaloes to horses. You just can't really do that in the realm of algebra. So you just leave it like this. I'm Jason. I hope you've learned something in this section. We've covered a tremendous amount of material. Subtracting fractions, I hope you see now, is really no harder than adding them together. I could have combined the sections together, but I really wanted to give you a lot of problems, give you a lot of practice, and show you that sometimes in math, when you think you're learning different skills, it's really just some of the same stuff you've learned before. So adding and subtracting is a good example of that. We check the common denominator. That's the same thing that we did before. If we have a common denominator, then we proceed. If we don't, then we have to find our own. All of that's what we did before. The only real difference is that I'm subtracting in the numerator instead of adding. So really it's the same sort of process. When you get the answer, you check. If it's not simplified, then simplify it. If it's improper, go ahead and convert it to a mixed fraction if you can, or if your teacher wants you to. When you get into higher level math, you don't even really need to do that. You can just leave it as an improper fraction. But for now, go ahead and convert them back. It's probably what your teacher's going to want. Practice your problems. Watch the section again if you need to. Work these problems out again if you need to. Get this right. Make sure you really understand it. Now, I've got a good piece of news for you. The next section is going to be on multiplying fractions, and then we're going to get to dividing fractions. That's actually easier than adding or subtracting them. So, look forward to that. I'm Jason. Go on to the next section. Promise you, you'll do well in fractions. I cannot stress enough how incredibly central it is to understanding fractions when you go through the rest of algebra. So make sure you really do get it. Practice your problems.